Hey buddy, so we're going to do antiderivatives and indefinite integration. All right, pretty much the basic idea of this is we're going to be going backwards on differentiation. All right, so we've been taking derivatives, now we're going to go back to the function before we took our derivatives. All right, so let's start with a simple notion of a function. Let's introduce this new format, which is capital f of x. So this function capital f of x is a function such that when I take its derivative, all right, I get little f of x, all right. So this now is the derivative, all right. And this is called the antiderivative. Derivative. In Spanish is derivada, antiderivada or derivado, I don't know. But yeah, so all right, so this is what we're going to be doing. So now let's start an example. If I tell you that I have a function f of x equals 3x squared. Now the question is, can you tell me where this function came from? What did I have to take the derivative to get 3x squared? All right. And for that, let's remember the fact that if I had x to the n, if I take the derivative of that, is n times x to the n minus 1. All right. So think to yourself, what is this antiderivative capital F of x function such that when I take the derivative of this baby, I'm going to get this here. All right, so that would be any guesses? It'll be x cubed, right? So we say, right, so and the problem is when you have any number here, so plus 5, well, the derivative of this is 3x squared plus 0, all right, so which is this, all right, plus 6, all right, 3x squared plus 0 minus minus 9. All right, so it's still 3x squared plus 0. So in fact, we say that an antiderivative of this one is actually capital F of x equals x cubed plus c. All right, this c is called a constant of integration. All right, so the first rule is if I take the derivative of a constant, we know that the derivative of any constant is 0, right? So then if we go backwards, what is the antiderivative of 0, all right? And respect to what variable? With the variable with respect to x, all right? What is the integral of 0? Well, the integral of 0 is just any constant c, all right? So that is the first rule, that if the derivative of any constant is equal to 0, then the integral of 0 is just any constant c. All right, so that is rule number 1. Rule number 2 says that if we take the derivative of a product function, all right, we know that if the derivative with respect to x of kx is equal to k, then and this is a number, remember, all right, what is the integral of such number k with respect to x? All right, well, it's nothing but kx, right? But remember, there could have been a constant attached to it, so it's kx plus c. All right, so let's see, what does this look like? The derivative with respect to x of, oh no, the tip of my pen is falling. The derivative with respect to x of 3x, right? The derivative with respect to x of 3x is equal to 3, all right? Well, the integral of 3 with respect to x is equal to 3x plus c, all right? Rule number 3, all right? The derivative with respect to x of k times f of x, all right? So this is equal to, all right, so rule number 3 says the derivative with respect to x of k times a function, right? We said that we always keep the constant, all right? And what is the derivative of f of x? Well, f prime of x, right? We know that. So then the question is, what is the integral of k f of x dx? All right. So in order to do that, it's like, what is the integral of a constant times a function? Well, the same trick. We hold a constant, right? So we can actually pull the constant out, and this is equal to k times the integral of f of x with respect to x. All right. So and then you go ahead and you take the integral of your function. This is just a property. All right. Property number 4. This is, if we take the derivative with respect to x of the sum or the difference of two functions. All right. Well, if we take a random guess, we knew that that was going to be f prime of x plus or minus g prime of x. All right. Well, what is our integral one? The equivalent of the integral was the same thing. If I take the integral of f of x plus or minus g of x, all right, with respect to x. All right, remember, every time that you take a derivative, the power, your degree goes down by 1. All right, so that means that taking an integral, your power should go up by 1. All right, so we know that it should be something like x to the 8th power, right? But now check what happens plus c, right? If we take the derivative of this, what do we get? We get 8x to the 7th power plus 0, right? Which is just 8x to the 7th power. We don't get this x to the 7th power. All right, so if only there was a way to turn this 8 into a 1, all right, you just make sure that it's not there. All right, well, that would only happen if we should be able to divide it by 8. All right, and this will be 1. All right, but we cannot just introduce this 8 like this. All right, so let's see, where is this 8? This 8 is actually here. And what is this? This is nothing but n plus 1. All right, so it seems like the formula then should be what? This is one of the ones that you're going to be using the most. All right, so the integral of x to the n power with respect to x is equal, well, it says we have to go up a power. All right, but remember, we go up a power and then we only go up a power and we take the derivative, we end up with this power here, right? The one that we went up by. So we want to be able to divide it by n plus 1. All right, plus c. All right, this one is the power rule for integrals. All right, now you can do every problem. All right, so let's see, let's do more examples.